Hello everyone, my name is Harry and I'm really bored. I need something to do. Tomorrow, me and my friend Luke are recording another episode of our podcast, Playing Favourites, available on all good podcasting apps. Download, listen, we talk about our favourite things in various topics. So I need a small project to fit in before I start editing that tomorrow. And thus, Harry's Guide to Cool Things in Space was born. Oh, and by the way, whilst that logo is pretty cool, it doesn't really do its job very well. In it, space emerges out from inside the Earth, which, as we all know, in 2020, that isn't how that works. But that wasn't the case during World War II. During the war, a Nazi infrared expert was sent out to the Isle of Rügen to spy on the British. The belief at the time was that the Earth was hollow, so the scientist, thinking that the curvature of the Earth wouldn't be a problem, pointed his observation equipment up at a 45-degree angle, hoping that you could get a good look at the British fleet. My favourite line in the book that details this is the last one. The experiment did not work. Oh good, now there's some smooth jazz playing, I feel I can finally talk to you about space instead of bizarre Nazi plots. Let's start with a dumb hole. No, that isn't an insult. Well, I guess it could be, but it's also a cool space thing. A black hole is an area in space-time where the gravity is so potent that nothing, not even light, can escape its grasp. Or more simply, big suck hole of death that nothing can escape from. A dumb hole, on the other hand, is an area in space-time where nothing slower than sound can escape. Jeff Steinhauer, a physicist at Technion University in Israel, actually created one of these in a lab to measure Hawking radiation. Pretty cool stuff. Dumb holes and black holes are known for their impressive sucking power. But let's talk about the inverse. There exists in hypothetical physics a thing called a white hole. White holes are incredibly complicated, but here's the best casual coffee table explanation I could put together. Gravity affects time. It's a bonkers concept, but it does. The more intense the gravity, the slower that time moves. That's why once you fall past the event horizon of a black hole, there's no coming back. It would take infinite time for you, or light, or anything else to escape. The potent effects of a black hole's gravity are described in the Schwarzschild metric. This metric refers to a totally imaginary black hole that is eternal. There's no charge, no spin, no change. We're working with hypothetical physics here, so it's allowed. If you were to look into this Schwarzschild black hole, all events happening at the event horizon are taking place infinitely far in the future, because of that crazy time dilation we were talking about a moment ago. You are taking notes, right? In reality, a black hole is formed when the core of a massive star collapses into a hyperdense singularity. That's the facts of the universe, our universe. But the hypothetical Schwarzschild black hole, this idealized, eternal, perfect black hole, what does that look like in the past? Well, if you follow that super complicated Schwarzschild metric infinitely backwards to find out what this perfect black hole would have looked like in the past, you get a white hole. An impenetrable area of space-time that cannot be entered from the outside and does nothing but spew out bucket loads of light into the surrounding area. A black hole is black because it sucks in everything, even all the light around it. A dumb hole is a black hole, but scaled down to the sonic level. And a white hole is the totally theoretical opposite of a black hole. Hell, white is even an understatement. If a black hole is the blackest black that could ever possibly exist, then a white hole is the brightest, most impossibly white thing that the universe could ever possibly conjure up. Other than Starbucks. Goodness, that's more hole chat than a particularly dedicated golfer, or perhaps something a bit more sinister. Let's move away from the holes and into the hot. The really, really hot. Bright, too. It's a quasar. This section of the video is about quasars. Quasars are the brightest things in the universe that actually exist. Remember that white holes are just theoretical. And funnily enough, their origins are actually tied to black holes. A feature of black holes is a thing called an accretion disk. It's a bunch of space junk like gas and light that orbit around the black hole when it's snacking on a star or something. And for the biggest and meanest black holes, those accretion disks can get big and fat. That light and energy and plasma from the accretion disk grinds together and heats up, accumulating further as the black hole feasts and more space guff is pulled in, burning bigger and brighter until you're left with a massive, swirling vortex of heat and light. And thus, a quasar is born. But here's another thing. Let's take a short intermission into the past, Harry's guide to old space. When the universe first started out as an angry storm of hydrogen and stars began to take shape, it was rather short-lived, as those same stars would quickly supernova. The universe was unstable, young and foolish. But, eventually, in this chaotic period of the universe's infancy, portions of the gas that was fueling the repeated death and birth of stars began orbiting around black holes, making accretion disks and then quasars. As I mentioned before, quasars are hot, like
super hot.
And the thing about hot gas is it can't really collapse into a star. It gave the universe a chance to settle down and allow for galaxies to get started properly, as well as for the relentless chaos to finally come to a halt. Quasars, these massive, fiery, swirly death rings, are like, well, they're like our galaxy's mum. So, shout out to Sagittarius A star for being a big spinny ring of hot gas in its youth, and for giving us the galaxy that we live in today. No, wait, don't go yet. I know the ending of that section of the video was a bit weird with me, sincerely thanking a black hole for its existence, but there's one more thing I want to talk about. Chance. The whole universe thrives on chance. All of the topics we've covered today are fueled by random numbers and galactic phenomena taking path A over path B. Not because a quasar is sentient, but because it got lucky. You too got lucky. Your existence isn't guaranteed, it was actually an impossible cosmic fluke. Imagine all the chaos in the universe, on the macro scale, like the ultimate fate of a star, and also on the micro level, like all the bacteria in a lake or the thoughts in someone's head. The number of different individual outcomes is far beyond comprehensible. Hell, even a single deck of cards alone has this many different arrangements. And let's compare that to the number of atoms in the visible universe. That's staggering, and it fits in the palm of your hand. I have 9 decks of cards within arm's reach. But then there's you. How many different things could have gone wrong when making you? Well, this graphic from visual.ly actually gives us the odds. The chance of your parents meeting were about 1 in 20,000. Then you multiply that to include factors such as them talking, dating, and then also going on to have children. From there, you need to think about sperm and ova and the chances of them having the right DNA to create you specifically. This puts our current odds as about 1 in 400 quadrillion. Quadrillion, though, that's a number you might have heard of, except we're not there yet, because we need all of these things to happen for your parents, and your grandparents, and your grandparents' parents. We need to go all the way back through every generation until we reach the primordial ooze from which all life emerged. A single deck of cards has this many possible arrangements. 8 unvigintillion. The odds that you would be alive and exist right now to be here watching this video doesn't have a name. It's 1 in this. I couldn't quite believe it when I saw it either. I thought maybe it would be double, triple, maybe even quadruple the cards thing, but no. I really quite enjoy the way that ScienceAlert.com wraps up its article on this subject. The infographic finishes by letting you know that the probability of you existing is pretty much zero. This means that you are the textbook definition of a miracle. How does this tie into a video about supermassive black holes and giant swirly fire death rings? Well, all of those are pretty predictable and well observed. But there's one space phenomenon so unlikely to happen and so different from everything else that I think, personally, it has to be the coolest of them all. The neutron star is that, no, idiot, it's you. I'm talking about you. So thanks for watching. Take care of yourself. I'll see you in the next one.